Welcome everyone, good afternoon. Today is coming to an end slowly. I think one more after this one, right? Yes. Okay. Just to set the scene a little bit, this is a story about doing desktop development on Windows. Okay, something you don't see very often anymore at conferences. It used to be the other way around years ago. But still, I like to talk about this. I like this technology. I strongly believe the desktop or apps for the desktop still have a very good reason to be. I'm always happy to see people joining me in this. It's not the biggest room, it's not a full room, but I'm sure you all have something with desktop apps and that's why you're here. Who is actively, professionally building desktop applications right now? Everyone, okay. Who is doing it in WinForms? WPF? Most of you. That's actually a first. All right. Anyone using WinUI or the App SDK already? No one. Perfect. You came to the right talk. MFC. That's in WinForms as well, no?
No, that's WinForms. It can be WinForms too.
Yeah. All right. Good. Okay, the Windows App SDK. Let's start with a small history of the different frameworks. So back in '91, Microsoft released this thing called Visual Basic, VB1. A visual designer, you could drag and drop your windows together and you could build an application using Visual Basic. In 2002, together with the release of .NET, they released WinForms. So you had VB1, 2, 3, up until 6. Then came WinForms, which was basically the next version of doing this, and included a new language, C#. 2006, WPF came to be. Now, what was so special about WPF? That was the rendering engine. Where WinForms was mostly based on software rendering, WPF went to DirectX. And this was, if I'm not mistaken, around the Windows Vista timeframe. And the problem was that it's a very good technology with a lot of possibilities. You can create great animations in WPF, but the computers at the time were not powerful enough to run these things, especially the business computers that didn't have strong graphics. And graphics, especially on-board graphics, have come a long way since then. They were not powerful enough to run the more complex WPF applications. So it took a while before WPF took on, which proves my point that I just made, that it's one of the first times that I know that there are more WPF developers in my room than WinForms. So even now, it's still... In 2012, we were in the Windows Phone, Windows 8 area, or time frame. They had this thing called the Windows Runtime, WinRT, and this was going to be the successor of WPF. This was going to bring universal apps to life. You could build it once, run it on your Windows Phone, Windows Mobile, whatever it was called back then, and your Windows 8 computer at the same time, same code base. Nice promise. They didn't exactly come through with it. Has anyone done Windows 8, Windows Phone 8 apps? No one? Someone? I'm sorry, I was there too. And then in 2015, the promise of the universal app that runs across all devices came into a new life with UWP, the Universal Windows Platform. And initially, this would run your app that you write once on your Windows Mobile 10 device, on your Windows 10 computer, your tablet, your HoloLens, your Xbox, across all those things, even on your Raspberry Pi, because that thing also ran Windows 10. In a headless form, mostly, but it worked. And this was actually a promise they kind of delivered on. This worked pretty well. But if you compare UWP to WPF, there was a lot of stuff missing. You cannot do any windowing, for example. You could not create new windows within the same application. You had no control over the title bar and so on and so on. Who has done UWP development? Only for Windows or mobile devices as well? No mobile? No? Oh well. I honestly still miss Windows Phone. I liked it. But okay. Fast forward 6 years, 2021, WinUI is released. Now, with WinUI, they took the controls, the XAML-based controls for UWP, and they started pulling it out of band. They started to pull it out of the framework with the intent of shipping them as a NuGet package. Because with UWP, with everything built into Windows, if they wanted to release a new control for UWP developers, or they wanted to fix a bug or whatnot, they actually had to release a Windows update, which was kind of a hassle. To update a developer framework, you had to update the operating system. That something was wrong there. So they started pulling those things out. And WinUI is now on its third generation, and WinUI 2 and 3 are living side by side. Because they had to make a big breaking change because it was too much ingrained in there to completely pull it loose. So with WinUI 3, there are a lot of breaking changes, and you actually have to create a WinUI 3 project in order to use it. But we'll get to that. WinRT is considered over and out. And if the clicker still works, there we go. WinForms, WPF, UWP, and WinUI are targets for the Windows App SDK. And that's what today's story is about. My name is Nico. I'm an application architect from Belgium. I'm a Microsoft MVP in developer technologies. I run a local user group. I'm also an author. I wrote a book on .NET 6, which is still viable. So if you feel inclined, you can buy it. It has a chapter on WinUI. I also brew beer. I ride a Harley Davidson, and so on and so on. You can find me on Twitter and on Mastodon. So if you should have any follow-up questions after this talk or after today, feel free to reach out to me. What are we going to talk about today? The history of the frameworks, we just did that, so that's over. Now we're going to discuss the App SDK. What is it? What's in there? We're going to talk about WinUI, which is the biggest part in the SDK. We're going to talk about packaging deployment for apps, and we have some time for questions, maybe. I don't know. We'll see how it turns out. This is quite a demo-heavy presentation. I have a couple of slides just to tell you some things, and then we're going to demos, a lot of demos, because that's fun. We like code, right? So the Windows App SDK is a set of components and tools. So there's WinUI on one hand, for example, but it also has several components, tools, modern way to interact with the new versions of Windows. Because WinForms, WPF are pretty alive, right? They were pulled back into modern.NET ever since Core 3.1, but they never got the modern APIs, for example, for the notification center or for the Windows 11 widgets. And that's what the App SDK is for. It's pulling those older frameworks into a unified API. The unified API. It's completely decoupled from Windows. It's on NuGet. That's the NuGet screenshot right there. This screenshot was taken 10 minutes before this talk started? No, 15, 20. And at that point in time, they had 2.3 million downloads. Just to give you an idea of how many people are still doing Windows desktop development. That's 2.3 million downloads for this one package that not even all desktop developers are actually using. Oh, that's the wrong button. That's why it doesn't work. Release through NuGet. Or you can install it through the Visual Studio installer. There are some templates in there as well. If you want to make use of those WinUI templates, then you go to your Visual Studio installer, to the individual components, and you can add them right there. Other stuff you need for using the App SDK, for certain parts of it, mostly the deploying and the packaging, you need to have the Windows SDK installed as well. Windows 11 and or Windows 10, depending on what you want to target. Right. So these are a couple of the components that are in there. WinUI 3 is the biggest one, and we'll dive into detail in a minute. The dWrite core component has everything to do with rendering text. Rendering text from small screen to the biggest screen you can imagine. And no matter how big your screen, how dense it is, what the resolution is and so on, and the DPI, it will always be crystal crisp text. That's what the dWrite core does. And those are APIs in Windows, and with the Windows App SDK, we can leverage them. MRT core has everything to do with resources, with translations, multi-language. We used to have the resx files. Then in WinRT, I believe we had the resw files. This API merges them together. It uses the more modern resw files and can fall back to the resx files. App instancing is all about how many instances of your app can you have open. If your user double-clicks the shortcut again, does the current instance open again, or does it create a new instance? We now have full control over that. Same with rich activation. We can use, or we can attach a file extension to our application. So if we double-click a file, that our application opens with the file in there, or we can even use a protocol. Like HTTP :/ opens your browser, we can create something that opens our app as well. We get access to power management. We can read the state of the battery. We can see how much percentage is left or how healthy it is, depending on what version you're running on. We get full control over Windows. We can create a new window in our application. We can move it to several overlays. For example, if you go on Facebook, for example, and you play a video and you scroll down, the video will go to your bottom right corner, still playing even while you're scrolling ahead. That's one of the things we can do in Windows as well, using the Windows SDK. We can do native push notifications. You've all seen these, right? In the notification area of Windows, we can leverage that even from old WinForms applications. And then deployment is a whole new story as well, but we'll dive into that soon. We are currently at version 1.3. 1.4 is in preview and has been released first preview version 2 days ago. I was not brave enough to use that one for this presentation. I did try to convert all the demos to .NET 8, but that failed. So we're not there yet on the .NET 8 level. So .NET 8 is in preview, so that was to be expected. So everything you'll see today will be in .NET 7. With the Windows App SDK, we can target widgets for Windows 11. You've seen those, we can build them. With version 1.3, we can actually use C# to build them. With 1.2, it was only C++. So that's a major change. We can trim our app size down to make them as small as possible for distribution. There's a lot of new stuff in display information, APIs to read out what kind of display is attached. We have new elements in WinUI 3, like media player element, and so on. New way of building app notifications is in there, and we can completely customize the title bar. Full control over it. Then we are at WinUI, and this is the final slide before we go to the first demo. So hold on just a little bit more. WinUI is a new framework for building desktop-based applications. You can see this as the successor for WPF when we're talking about WinUI 3. It's .NET 6 and higher. That's what's supported. As far as operating systems go, WinUI supports Windows 10 update from late October and onwards. No Windows 7 support. Mind you, this is only for WinUI. The Windows App SDK, excluding WinUI, can target apps running on Windows 7. There are methods and properties in there to make sure that everything is supported or not. So you can change your code accordingly. But WinUI is only Windows 10 and up. As I've mentioned before, it's side-by-side with WinUI 2 because reasons. And we have support not only for the Microsoft-based applications, but we can also do React Native for Windows. That's the GitHub. If you run into any issues, you can log an issue there. There's an entire roadmap about where they're going with WinUI. This is all very much in the open. Source code is there, roadmap is there. They do monthly stand-ups, I believe, out in the open. You can just join and watch them, discuss things, and chime in on chat. Let's have a look at this. First of all, is this big enough for the people that are more in the back? It's readable? If it's not, just give me a shout and I'll zoom in a bit. But I have to make sure I can still read it as well. Okay, we're going to start out with a new project. And I'm going to look for WinUI. WinUI. Here we go. So I have a couple of WinUI templates. And what's the difference between them? It's the languages. So in the tags at the bottom, you can see C++, C#, Visual Basic, which is not on the screen, but it's there. It does exist somewhere. I'm going to do a blank app packaged. What does packaged mean? Let me create it first. Give it a useful name. App 8 sounds perfect. All right, what does packaged mean? Have you ever heard of the Windows application packaging project, the MSIX? So you have MSI, which is the old way of creating an installer and so on. MSIX is the new way. And this is actually the reason why you need to have the Windows 10 or 11 SDK installed, even though you're not building UWP apps. The installer projects are UWP based. And why do you need to have this? It's because when you add a package to your app, it creates an app identity for you. And you need to have this identity if you want to do things like push notifications, or if you want to have, like if you right-click on the taskbar in Office, for example, you get your most recent files in that jump list, right? If you want to do that within your own application, you need to have an identity. That means adding a application installer package to your app. There's some more reasons why you would need it, but those are the two most common. All right, so this is a WinUI app. As you can see, there is no package project in there. In the past, if you ever did that for UWP or whatnot, then there would be a separate project in the solution. And we will see that when we're doing the WinForms thing. But for the WinUI templates, they actually merge it together, so we only have to handle one project. Makes it a bit easier for us developers, but it's basically in there. And you can see that by the package.manifest. This is where you declare file types that you want to attach to your application to be used, or your protocol handlers, and we'll see all of that stuff. For the rest, this is basically, most of you are WPF developers, so this should be very recognizable for you. We have an app.xaml.cs, which is the entry point of our application. There's some initialization there. It opens a main window, and the main window is basically a window. If we run this, do notice that it says to run as a package here. Oh. You can run it unpackaged as well. So if you run it packaged, then it will, MS-Build will package it up first and then launch the package. If you run it unpackaged, it will just launch the code. It will look the same, but everything that needs an identity will not be debuggable. That's the difference. So this is it. This is basically the template. But we have a desktop application. We have all the live visual tree debugging tools that you're used to from doing WPF and whatnot. All right. If you want to see what's in there in WinUI, there's this app called sample gallery. No. WinUI 3 gallery, that's the one. It's installable from the App Store, from the Windows Store, and it holds all the controls that are in there. For example, the calendar view is right here. There's source code on GitHub that you can link to, or there's the documentation right there. All of the properties are here, and if I'm not mistaken, even the XAML can be copied from here. So the gallery is really a useful app if you're building a WinUI application. You can configure everything here and just copy-paste the codes into your app. Because the visual designer is not there. Let's see, we have the XAML. So there is no designer for this. But for us, it's basically your XAML syntax as you know it. It's not the WinForms XAML. It's really the XAML that you know from UWP that's been continued working on to be this WinUI thing. Shouldn't be too different from WPF, for example. There are some differences, and we'll get there eventually. But first, let me open a different project. So what I'm doing now is I'm opening a couple of samples from the Windows App SDK samples. They're all out on GitHub. You can get them there, but they're all quite small, and each of them demos a specific feature of the SDK. This one, for example, demos the resources, the MRT, so the resx, resw files. And once it starts up, you will notice a couple of buttons, and each of them loads in a different resource. We're getting there. There we are. So this is the application. If I click default language, we get an English sample down here. So default language has used a resw file and has used the default language that it got from my system. If I override the language, we get something in German. I don't speak German, it's just how the demo worked. The resource fallback goes to a resx file, a classic resx file, for example, out of an old WinForms application. And we can even load in resources that are coming from a class library. This is a demo that's not saying too much, so let's just go look at some codes. So for starters, if we look at the Solution Explorer, this is a class library with a resource file. This is the actual app with a resx file and 2 languages in newer resources files. And this is the app package that I just mentioned. This is an older demo. It still has the separate projects. So what happens? If we compile this, it actually creates a PRI file. And we can see this if we go to the File Explorer. And PRI is the package resource index. Way too many folders. Here it is. This is the one from the class library. If you scroll down a bit, there will be a different one. So this is a binary file. You cannot open it with Notepad or something. And this contains all the resources. And this is the file it's actually using to get its resources from. It bundles the different resource files that it found into one resource index. That's what it does. All right, code-wise. Let's start out in the app.xaml. So what we're doing is we're preparing a resource loader and a resource manager. From the resource manager, we can have a resource not found event that we can hook into. And then we can go look for a fallback. In this case, what it does is if it cannot find the resource we're requesting, we are looking in the legacy resources that are there to see if maybe there's a legacy resx file there that we try to get a resource out of. We are creating the new window, and we are passing the resource loader and the resource manager in there. Going to the window, we can use that resource loader to load a string, the sample string. So if we open up the default resource file, we have the sample string right here, the one that says English sample, and then the German one has the German thing in there. Okay, we are overriding the language here, and we have set a resource context to be a German language as well. So that's there for us, ready to use. And if we override it, we get the value, the sample string value, and we pass in that context, saying we want the German version of this. Override whatever default language you think you need. We want the German one. And then there is the legacy fallback. So here it will try to find a legacy string, but it cannot because it's not there. So the resource not found event will fire, and it will go to the legacy fallback method and pull that one out. And then this one is just to get it out of a class library. All right. Next one. Feel free to interrupt me if you have any questions, by the way. Next thing we're looking at is app activation. So before hitting the breakpoints, let me show you what this does. Activation is all about how are we launching our application. Okay, so this is a launched application. I launched this application by pressing a shortcut key, for example. Now, if I go to the folder where this application lives, which should be right here, then there are some foo files. If I double-click one, the application opens, and activation count is file, and the file name is right there, ready for me to open, to do things with, and so on. Another thing I can do is push Windows R, go foo, : //. It opens again. Activation info is protocol. Now, the fun thing about this is if I go back here, there is an index.html, which has a link. This could be a website. I can click it, open, and it opened my app. And I can pass in parameters from my website to my application. That's protocol launching. So if you are selling a desktop application as a product and you want from your website to actually open the app, this is the way that you can do it. But how does this thing work? For starters, to register the file extension and the protocol info, you need one of those identity things. You need to have a package.manifest. And if you open it, you have declarations. And there are two declarations in here. The first one is a file type association. I pass in the name and the supported file type. That's it. I can also pass in a logo, and this is, if I go back to my file explorer, you see that this is the logo that it gets. So the square with the cross in, that's the default store logo that you get for building store applications. It's been around since Windows 8. But this is the icon that I specified here in my declaration. Then there's a protocol. Protocol, same thing, pass in a logo that it should show, a display name, and then just the name of the protocol. That's it. It's as simple as that. No code required. Of course, you want to do something based on how you got into the application, and that's where the get activation info comes from. For example, if I set a breakpoint and I just launch it, So the get activation info is fired once I click the button. Let it boot up. There we go. Click the button. Move these things out of the way a bit. So I checked for the extended activation kinds, which is something you can request from your current app instance. The kind is currently launched, so this is launched by just opening up the application. And then based on that, I can fetch some data from the launch event args. There's nothing here because I just launched it, so you won't find anything. But if we scroll down a bit, and for example, it's launch kind file, then we can actually get all the files out there, because it can be more than one file that triggered this. You can select them both presenter, and there will be multiple files there. So we take out the first file, and then we get an iStorage item, and we can get the name, the path, and whatnot. If you launch through a protocol, we get an absolute URI that contains the everything, the complete URI with all the parameters, the query strings, everything that we put in there. We can even set this app to be a startup task and detect that. Like, we can have this start up with Windows, or once your user has logged in, to do specific things. Next one on the list is instancing. So I don't know if you've noticed, but I've opened this app a couple of times without closing it, and every time it restarted its instance. And we can have control over that one as well. So if I launch this application, it will look very similar, but we get a bit more info out of it. But it also has the file extension protocol, different one, but it's there as well. So what we have now is activation kind launch, called from main, it's there. If I go into that folder, it has two files, and this time it's .mu. If I launch the first one, there we go. It's a file, and it now this instance is registered as a key. This instance of this application has a certain key, meaning that if I double-click it again, and it wants to, did it do it? Let's just do it again to make sure. Yeah, it keeps on opening the same instance basically, but if I select a different one, oh, this is getting slow, then it opens a new instance. See, this one's the Shakespeare.mu, and this one is the, oh, it's actually launched a couple of times. See, every instance that we create can register itself with a certain key. The key should be unique to the instance, of course, and in this case it's easy, we just use the file name, but it can be whatever. And let me show you how that works. If we go to program.cs, where are we? Let's close this region and this one. Nope, other one. So we have a decide redirection that we get into. So here it is. We find or register a key. Find or register, meaning that if it doesn't exist yet, we create it, and this instance will be created under that key. And then we can check the key instance to see if it's the current one. If it was, then that means that this is a new instance. If it wasn't, then we have to redirect to reactivate the old instance. And then we have here the on-launched event, where we can hook into these things and actually make sure that we do the correct thing, like create a new instance. All right. Windowing. That's one of the last things I want to show before going to WinUI. The power that we get over control of our windows. Let's just fire it up. It's about creating a new window for your application, secondary, third window, and so on and so on. Having control over the title bar, even having emoji or Unicode support in your title bar, for example. Being able to resize your window just like that. And as you can see, it resizes nicely. The title bar, we can toggle color customization. So we can make it a different color, or we can make a fully custom one. Now, as you can see, we can drag this around. It still looks like a title bar. I can make it a bit taller. But this is actually a XAML element in my own code. This is XAML in the application's code. This is not an actual Windows title bar. It looks like one because I've styled it like one, or at least Microsoft did when they built this demo, because your user expects it to be one. Now, why would you do this? If you look at Visual Studio, for example, to its title bar, there's a search box in there. If you want to do this in your own application, the default title bar does not support that. That's why you need a custom one. But a custom title bar by default is now draggable, so you need to write that logic as well, because your user expects to be able to do this and this. So let's reset the title bar back to normal. And then there are the presenters. If I, for example, click Compact Overlay, this happens. And this is the example with the Facebook video that I just gave. So these are built-in presenter types. The Compact Overlay is one of them that just makes it small, but you can still, oh no, you can't even resize it. So it's stuck in this way now until you click Exit. Or you can go full screen if you're building kiosk apps. And you can just go back to default. And then you can create a bunch of new Windowses, all within the same application context. And you get full control over where they are. Like that, for example. You can move the order around. You can set the Z order. You have full control over these things. And for the longest time, this was the biggest pain point for people doing UWP. Like you couldn't even tell a UWP app to start maximized. It always started like in a window somewhere random across your screen, which is not what you want if you're building line of business applications, right? Okay, so how does this work? We start with a windowing interrupt class. And if you're going to do this kind of stuff, then I would advise you to go look for this demo on GitHub and actually borrow this class, because it's a bunch of helpers, a bunch of extension methods that help you get the handle towards the app window. And this will be the same thing in every application that you write where you need to do this. So no need to reinvent it every time. It calls into Windows interrupt to get the window handle. And that's all you need. From that moment on, you can call into its methods. For the title bar thing, there's quite a lot of code there. So there is the app window title bar class that you get, and there is an isCustomization supported method. This will return true if you're on Windows 11 and return false if you're on Windows 10, because Windows 10 does not support this full customizable title bar. So this is the way to check for that. So please do and adjust your code accordingly. And then you can set the title, you can set the foreground, background colors, even for the inactive ones. the buttons are like the three buttons in the top right. This is the reset back to defaults. This is the fully custom title bar. You can set the extends content into title bar to true, and from that moment on, it's up to you. What they basically do is they make the title bar disappear, and everything below is up to you now. And then you create the new one. But then you have to set the drag region for your custom title bar. And that's the interesting part here. You create a bunch of rectangles, and they should span over your title bar, your custom one, exactly. And you can set the drag rectangles to the title bar, and this is again the actual title bar. But if you pass it some rectangles in there for drag rectangles, then it will support all the things that the normal title bar supports. It just passes them through to your rectangles. So that's why you get drag support, why you can double click the title bar and it will maximize. You get all those things out of the box. All right. Let's go back to our app 8, the WinUI 3 app we created all the way back in the beginning. Let's save it so it formats. If you're doing XAML and you like to format it on save, there's an extension called XAML Styler. I'm one of the maintainers of it. It installs in Visual Studio, it installs in Rider. If you save any XAML file or a XML if you're doing Avalonia, then it will just format your XAML. A lot of settings in there to customize it as you see fit. After this small commercial break, we continue. So what we're going to do is, we have a stack panel here, we have a button here. Does anyone not understand XAML? Just so I know. Everyone? Perfect. I will add another text view, but a text block. You might see me make mistakes in XAML, but that's because I'm doing XAML WinForms, I'm doing MAUI, and doing this all together, and they're different dialects. So forgive me on that one. I'm gonna add a binding here to a counter property, not do the horizontal thing. Like that. Okay. And I'm going here. I'm going to add a property, integer type, counter. There we go. Whenever we click the button, counter plus plus. This is the most basic data binding demo that's there. This is the hello world for bindings. Pop quiz for all you WPF developers out there. Will this work? Why not? Sorry? I notify property changed. Very good. With the power of ReSharper, I can implement this quite fast. And I can change this to a property with a onProperty changed notification. Will this work? I see some doubts, I see some yes, I see some maybes. Let's find out. This suspension is killing me. Nothing is happening. I don't even see the default 0 value of the integer. I am missing one very important thing. How does a binding know where to look for its properties? Data context. Yes. There is no data context set. Okay, so we need to do that. But, and here's one of the big differences in WinUI. And let me zoom in for dramatic effect. There no longer is a data context property on the window, because window is no longer a framework element. That's a big change. Data context still exists, data binding still works, but window needed to be changed in order to support all the fancy windowing APIs. So it's no longer a framework element. But okay, that's an easy fix. I just named my stack panel, call it root. Root.data context is this. Anyone wants to take a guess if it works now? It does. This works. Okay, cool. Why am I showing you simple binding demos? Because this is still there. Binding is still there because of backwards compatibility, but it's no longer the preferred way to go. Why not? Because binding relies heavily on runtime binding or runtime inspection things. And those things are slow. And for example, if I mistype this by adding a small c, it compiles, it runs, it just doesn't do anything because it's runtime inspection. Now, if I want to change this, I can go from binding to xbind. Xbind was first introduced in UWP, and this is actually compiled bindings. So what this does is this gets resolved compile time. It generates C# code that gives a name to your text block and that says this text block.text equals this. If that changes, then this text block.text equals this again. So it compiles into C#, which gives you an incredible performance win. And added value, you get support here for typos and even IntelliSense. I can just find my counter right here. And I can even click towards it if you're using an object. So there is that. Even more, because it's compiled bindings, it does not need a data context anymore. Xbind completely ignores data context, which is a problem in an MVVM scenario, and you have to actually add a property here that points to your VM as a workaround. But that's something you have to live with. That's you break the pattern a little bit, but you get a big performance win in return. All right, let's try this out. Cool, my 0 is there, so my binding has worked. But if I click it, nothing happens. Any takers on why? No one? There's this thing called the binding mode. In classic binding, binding mode was set dependent on whatever type you are binding against. Like any input type would have the default of two-way binding, anything else would have a default of one-way binding. The binding mode that you set has an impact on your performance. So by default, they have set this across the entire Xbind framework to the same value, being one time. Resolve when it opens, and then ignore it. So you have to set it to one way explicitly. Run it again. And now this works. Cool. All right. If I'm not mistaken, we have about 12 minutes left, which is perfect. So that was just a quick demo on WinUI and the new binding framework, just to prove to you that this is not just WPF in a new jacket. There actually are some really big improvements in there. Now, something else that's really new, and they've been working on since WinUI 2, is the use of XAML islands. And what the XAML islands are, they are a technique or a set of APIs to pull in the newer UWP controls, the modern controls, into the older frameworks like WinForms. We can host UWP controls in a WinForms app. And to demonstrate this, I have this old WinForms app, and if you ever seen any presentations about me, from me, you will have seen the pixelator. What it does is it takes an image and it pixelates it. And you can set it to whatever. It's pretty useless now. It's been used to win a post-it war against our Java unit at work. They never figured out how we did it, but we cheated. But the thing is, this is a WinForms application. It was built in .NET 4. It has been updated all the way to .NET 7. That's where it's now. This is WinForms running on .NET 7. The reason I'm showing you this is because there is a form in here that hosts a web view. This is the basic WinForms web view that's included in the box. And even though we're running on .NET 7, it says we are using IE 11 on Windows 8. This is not IE 11, this is not Windows 8. I can promise you that. But the engine that's in there is still the IE 11 engine, even though we're using a newer framework. And we want to fix that. A way to fix that is by using the web view control that's in UWP, that's based on the Chromium Edge. So to do that, we go to NuGet, and there is a web view 2 control on there. And this control actually leverages XAML islands under the hood. I'm not going to implement the full XAML islands thing because that's pretty involved. It's not that easy to use. But there are a lot of controls out there, even in the community toolkit, that use this technology to bring newer controls into older frameworks. And this is one of those. Let's just install this. There we go. I'm going to open the form. Loading the designer. Still slow. So I just deleted the WebView control, the classic one. The WebView 2 is in my toolbox now, coming from the NuGet package. Put it in here. Give it some size. Press F7 to go to the code behind, because this now changed names. It's not .url, it's .source. And this just points to the website that you just saw. If I run this again, you should hopefully see something different. We are using Edge 113 on Windows 10. Closer, not quite there, but closer. But it's the best I can do for now. Now, let's say I want to ship this application. I have an old WinForms app. I want this to have push notifications. I want this to have an identity. I want to ship it. What I need to do then is go to NuGet once again and look for the Windows App SDK. So I've been talking about this for 53 minutes and now we're getting to use it. Now this is just a NuGet. If you want to put the App SDK in older applications, then you go through NuGet. If you use WinUI 3, then you are already using the App SDK out of the box. That's the difference. Ignore the error that you get here. That's fine. It's because we need to edit the project file now. And where it says .NET 7-Windows, we have to change it to a specific version of Windows. Like this. I have to add a runtime identifiers that says WinX86, WinX64, if I'm not mistaken. There we go. Let's ignore that again. Open up my main form. So that's the basic bootstrapping that you need to do in order to get the SDK working. It needs Windows 10. That's why you need to do that. So this is the button click event handler to open the image. I'm just going to reuse this for now or abuse it. And what I'm going to do is I'm going to add notification. That's a new app notification builder. Build notification. That's probably the wrong one. this one. Okay, so this is a class coming from the App SDK. And then there's the App Notification Manager. I want the default one. And then the .show and pass in that one. And once again, it's the wrong one. That's what you get for trying to be fast. And there we go. So this is actually using the App SDK to hook into the newer Windows notification thing. So I click the button, it should generate a native notification. It doesn't, it crashes. Why does it crash? Because it doesn't have a package identity yet. The thing I explained a couple of minutes ago. So in order to do that, I add a new project to my solution. And I can look for the MSIX. Again, different language supports. I need the C# one. I just add it, select my target and my minimum version of Windows that I support. And here we go. So this needs to be my starter project now. And I add a project reference to it that points to my actual WinForms app. There we go. Now it's right here, ready to go. So now I'm launching from the package, or at least I will if I change this to x64. So you can no longer use any CPU. Once you do it this way, you need to specify what CPU architecture you're running on. There we go. Click the button. Nothing seems to happen, but that's because my Do Not Disturb is on. And here is my notification. Native notification coming in from the WAP project template 1, which is the name of my package. That was actually the wrong button. There we go. And now, in the last 3 minutes, since we have a project template, I can right-click it. Once I stop running, I can right-click it and hit Publish to create an app package. And I want to create an app package for sideloading. Or you can create one for the store. You can put your Win32 apps in the store if you want. Paint.net is there, for example. I can create my self-signed certificate if I want to. I can select a non-self-signed certificate if I need to. You can sign your app with this. Click Next. Can have any configuration type, any CPU support that you want. You can version it right here. Hit Next. Here you can put in a path where it will go look for updated versions. So this is basically your click once that you used to have for WPF or still have. So it will look for new versions there every time you're on the application or automatically on a specific time frame. Then you click Create. Not going to let it do it because it takes a while. But what you will get then is the following. You will get this. So the app installer is where your actual MSIX file will be. But you also get an index.html file that looks like this. And this you can host somewhere, and you can point your users to this. They click Get the App, and this opens the installer. This will not work because this is an old generated installer. The certificate is long gone, it's long expired, as you can see. But this is the experience that you will get. The app installer opens, installs your app. The interesting thing is your app, if you run it this way, it runs containerized with the virtual file system and virtual registry. Meaning if you uninstall it, it's gone, nothing left behind. You know how your machine gets slower and slower over time because of things that get left behind? You solve this way. All right, going back to the slide deck, I skipped over a bunch of slides. but demos are more fun anyway. So yeah, small detail on the whole deployment thing. You can have your app to be fully self-contained, meaning you ship .NET with your app, the .NET framework, trimmed and everything that you want and shaken, but you ship it with your app, meaning it's up to you to install security updates with it. If you don't do it, if you don't do self-contained, that means that you rely on the .NET framework installed on the computers. It's one thing or the other. So all of these things are now being replaced by MSIX, but you can still use all the different setup wizard creators from the past, all those vendors. You can still use them within your MSIX. MSIX is just a container. You can put an install shield wizard or whatever vendor that you are using, you can still put that in there. We just explained this. Everything is containerized. There's no machine rots. All the updates that are coming in are differential updates. So it's not that it's every time uninstalling and reinstalling the complete app. Only the files that have changed are coming in. You can distribute this over the Windows Store, Store for Business, on a file share, on a SharePoint, or just an HTTPS endpoint, wherever you want. We have discussed most of this. There are some limits to MSIX. You cannot do Windows services with them. That's the most important one. Also, when you push it to the Microsoft Store, run as administrator is limited, and access to the file system and the registry as well, because they're virtualized. We went through this already. Key takeaways for this session is Windows App SDK, a way to pull in the modern APIs for Windows 10, Windows 11 into your older apps to make use of them in a unified way, whether you're using WinForms, WPF, UWP, or WinUI. And it's completely out of band with Windows, which was the whole reason that they started this journey. And they made it. It's completely out of band. Some resources. The complete documentation on the Windows App SDK is right there on the Microsoft Docs website. It's pretty complete. It's very well up to date. Your mileage may vary if you're already in .NET 8. It doesn't work yet fully, but they'll get there. And if you want to read a chapter in a book, there's this one. If you want to learn more about desktop development and what's coming and what's new from Microsoft, Microsoft Learn is the way to go. I'm afraid we're out of time for questions, but feel free to come talk to me. And that's it for me. Thank you all for being here.